Project number 1 is going to be the first 7 experiments out of our basic electronic experiments using our breadboard. We're going to do the first 7 projects there, and then we're actually going to do one LED project with our Arduino kit. So my name is Nanni, and this is for EE292 with Professor Pushkin. So this is the first experiment number 1, the light bulb, and the things were required was the 9-volt battery, 1 switch, 10 kilo ohm resistor, 1 LED, and 2 wires. And the instructions were to insert the red battery wire or positive power supply into J4, which I've done here, and also the negative power into hole -3. I inserted the switch into those 2 holes, the resistor, the LED, and the 2 short wires needed, just like they have in the picture so. And when we click on our switch, the LED lights up. So that is experiment number 1. Next, for experiment number 2, we are going to be doing the brightness control. So obviously we're going to be controlling the brightness of our LED. And the way we're going to be doing that is using this 50 kilo ohm variable resistor. Basically the same setup as experiment number 1, except now we are switching out our 10 kilo ohm resistor with the 1 kilo ohm resistor, and we're also actually going to change one of the positions of the short wire as well. So we've already have these first 4 steps completed. We've switched out the 1 kilo ohm or the 10 kilo ohm resistor. We inserted our variable resistor, and we've also switched one of the short wires. So here it's set up correctly with our new resistor, our variable resistor, and the short wires moved. So now I'm going to show you guys what we are doing. So this variable resistor, what it does is it controls the brightness of our LED. So if you move it this way, you can see the LED gets brighter, and if you turn it the other way, it gets dimmer. And that's pretty much it for experiment number 2. On to experiment number 3. For experiment 3, it talks about resistors in series. So we know from EE292 that if you have resistors in series, the sum of the resistors is going to be your total resistance. So here we have a 100 kilo ohm resistor and a 3.3 kilo ohm resistor, so obviously our total resistance is 103.3 kilo ohms. For what we did is we kept our power supply in the same spot, our LED and our switch, and also one of the short wires. We actually removed 1 short wire and our variable resistor from the last experiment, and we've inserted 2 resistors in series. So the one on the left is the 3.3, and then the one on the right is the 100 kilo ohms. So now when we turn it on, we should expect the LED to be much dimmer, which it is. And to kind of test that, we're going to remove the 100 kilo ohm and replace it with a 10 kilo ohm resistor, which we will do. So now the light should be much brighter since there's less resistance, which it obviously is. And that is our experiment number 3, which is resistors in series. Experiment 4 talks about resistances in parallel. So what we learned in class is that if you have resistors in parallel, we know that the total resistance is just going to be the product of the 2 over the sum of the 2. So in this case, we left our 3.3 kilo ohm resistor, and we actually inserted the 100 kilo ohm resistor in parallel. So we know that our total resistance is going to be the same as about like a 3.2 kilo ohm resistor. So now we also inserted 1 more short wire. So now when we take a look at our LED, right, it's pretty bright. So now so we know that the smaller the resistance, the brighter the light is going to be. So what we're going to do is actually take out the 100 kilo ohm, replace it with the 10 kilo ohm resistor, and then we're going to turn it on. And we noticed it's a little brighter, and it says that the total resistance is now only 2.5. So it says there wasn't much of a difference. It looks brighter to me, but it actually might be, it's a little dimmer. And now we're going to replace this 10 kilo ohm resistor with now a single kilo ohm resistor. So obviously, now that I have barely any resistance, there's going to be a lot larger flow into the LED, which means it should be really bright. So if we check it out, yeah, it's way brighter than the other two. So that right there is our parallel resistors. For experiment 5, we're talking about comparison of parallel currents. So the way that we're going to compare the two is we're actually going to compare two LEDs side by side with parallel resistors, and we're going to see how the currents are altered. So one LED will always be brighter than the other, and the way we did that is we left pretty much the same things from the last time. We changed where our 3.3 resistor was. We inserted 2 more short wires and that LED so we can connect that second LED. And now that we have our 2 LEDs set up, we're going to switch it on and see how we can compare the two. So obviously the one on the left is much dimmer than the one on the right, and so we're going to see if we can actually change that. And so the way I'm going to do that is take out the 100 kilo ohm resistor, and this one was in J5, J12. Take that out right now. I'm going to replace it with the 1 kilo ohm resistor. And now we're going to compare the two again. And now it looks like the one on the brighter is, or the one on the left is a little bit brighter than the one on the right. So obviously when we have 2 parallel LEDs, changing the resistors obviously changes the current and therefore changes the brightness of the 2 LEDs. It's experiment number 5. So here we have for experiment 6 the combined circuit, and what we're doing now is we're going to be actually basically doing everything that we've already done up to this point, and now we're going to reuse our variable resistor, and now we're introducing a second LED, and we're going to turn that variable resistor and notice a change within the LEDs and the way that the currents are flowing. So it says here that with the dial turned all the way to the left, the VR is 0 ohms. And so only one of the LEDs should be on, and then when we turn it to the right, it should, about halfway, they should be about the same. And then if we turn it all the way to the right, the left one will be a little dim and the right one will be brighter. So we used ideally the same setup with now our variable resistor. We changed the positions of our 2 resistors and we included another short wire. So if we look here, I have it turned all the way to the left, so when we turn it on, only one of the lights should be on, which it is. And now when we turn the variable resistor to the right, we notice that they get the same brightness, and we keep turning it to the right. We notice that the LED on the right gets much brighter than the one on the left. And there we have our combined circuit. For experiment number 7, we have the water detector. So what we're doing is we're basically disconnecting our connection for our LED, and we're going to kind of remake that connection just by using water and salt. So we have our setup completely set up with all of our resistors and our disconnected wire. And now we are going to put it in the water. I already put a little bit of salt in it, and just see if our light turns on. So here, So when we put it in the water, we notice that the light is already dim. And if I add a little bit more salt, we see that it gets brighter and brighter because now the connection is stronger. And that is experiment number 7. For the last piece of project 1, we used our Arduino kit, and our assignment was to use the code to just have an LED blink on our Arduino. So what I did is installed all the drivers and ran the code for blink every 1 second. And as we can see, the LED is blinking every 1 second. And so just to kind of play around with it, I'll change let's change these to 500, so it should be blinking faster. And upload. So we know it works, and it's obviously up blinking faster than it originally was. So that was the final step for project number 1, and can't wait for project number 2.